Some of the most astonishing discoveries made by the powerful Webb telescope won't come from pretty pictures. Instead, the instrument can detect what the atmospheres of extremely distant exoplanets or planets beyond our solar system are composed of. In July of this year, NASA revealed that the James Webb telescope had detected the distant signature of water on a hazy exoplanet 1,150 light-years away from Earth. It is not the first detection of water molecules on another world, but the Webb telescope, built with a 21-foot mirror more than 2.5 times larger than Hubble's, allows unprecedented views into these distant planets. While the Hubble Space Telescope has analyzed numerous exoplanet atmospheres over the past 2 decades, capturing the first clear detection of water in 2013, Webb's immediate and more detailed observation marks a giant leap, though, toward the quest of characterizing potentially habitable planets beyond Earth. So, who knows what we can discover on Wasp 96b and future exoplanets in the future. However, the telescope Webb is spending considerable time, 25% of the first year, peering into the skies of exoplanets. This particular world, for example, Wasp 96b, is nothing like Earth. It's a type of planet called a hot Jupiter that doesn't exist in our solar system. Wasp 96b is a world a little larger, though less massive, than our gas giant Jupiter that sits extremely close around its sun-like star, but temperatures are hotter than a pizza oven, exceeding 1,000 degrees Fahrenheit. To detect molecules, though, like water, methane, and carbon dioxide on distant planets, astronomers point the telescope at known exoplanets in our Milky Way. Then they'll just wait for planets to travel in front of their bright stars. This starlight passes through the exoplanet's atmosphere, then through space, and ultimately into instruments called spectrographs aboard Webb. It's a strategy called transit spectroscopy, which we talk about in this video. They're essentially like high-tech prisms which separate the light into a rainbow of colors. Here's the big trick, though. Certain molecules, like water in the atmosphere, absorb specific types or colors of light. Each molecule has a specific diet, right? So each diet has a form of way to detect that kind of molecule. For example, if the color doesn't show up in the spectrum of colors observed by Webb, that means it got observed by the exoplanet's atmosphere. In other words, the element is present in that planet's skies. So the spectrograph produces lines designated different types of light, not pretty pictures, but it's a wealth of invaluable information. The spectrum of light recently captured by Webb shows that the Wasp 96b blocked light waves from water molecules, meaning there are water molecules present in its thick, fluffy clouds, which is very interesting and weird. Could there be life? Is it habitable? Well, the atmospheric composition of Wasp 96b indicates the presence of water. The Webb telescope's near-infrared imager and slitless spectrograph, or NIRSS, captured this detailed data while peering at Wasp 96b for just over 6 hours. Planetary scientists are excited about what else they'll find on other distant worlds. This nearest observation demonstrated that Webb has the power to characterize the atmospheres of exoplanets, including those of potentially habitable planets, in exquisite detail, which is something that NASA has been dying to see for decades. Webb scientists, however, plan to also point the powerful telescope at rocky Earth-like worlds. There could be well over 1 trillion exoplanets in our galaxy alone, but we know nothing about them. We've only been barely scratching the surface, so it's really exciting. If you like this video, then you really are going to love this video right here, because we delve really deep into the Carina Nebula discovery with James Webb and what it potentially could have or host, asking questions like, does it host alien life? What do these cosmic cliffs even mean?